Hello, everyone. This is Solomon. I'm Henry, sales manager of Europe region. And today I have my senior engineer, Brendan. Brendan, say hello to everyone.
Hello, everyone.
Okay, so today both of us will introduce you SolVision products, which is really powerful AI inspections software to you solve your problem, which maybe you cannot solve in the past. And we will introduce today the features and the interface and also some applications. So let me start with my presentation. All right, so for someone who doesn't know Solomon, we are listed company in Taiwan. We start from 1973. And we start from some automation business like the robotics distributions, like UR, Kawasaki, or Toshiba, those robots. And also we distribute Rockwell as a really biggest automation component distributor in Taiwan. But for the recent 5 years, 6 years, we develop our own AI vision. Together with the robotics, we bring you the totally brand new AI 3D solutions. We have a worldwide offices start from Taiwan, US, we have 2, and the Southeast Asia in Vienna and Thailand, also in China. We actually plan to have a Europe office in this year. Hopefully the coronavirus can be solved in really quick. We can wait longer. So this is our future plan. And we have so many different partners in Europe so far. We welcome you to contact with them. And for some regions, we still don't have partner. We also welcome to join us. And together, we can grow up together to introduce this software and total solution to the worldwide customer. So Solomon Vision Suite, AI plus 3D, we have 3 main products: AccuPick for bin picking. We have a 2D, 3D bin picking solution for manufacturing. And for logistics, we have also AccuPick, also so-called Smart Pack. And for SolMotion is a robot guiding system in 3D. This is also one of our solution. Well, but today we only focus on the SolVision AI inspection tool. This is actually our core value, our AI software, which can integrate with the different 2D cameras. So let's begin. SolVision has 4 key features for you. First, if you are not engineer background, if you are the first market player, you still want to do some inspections, high-level advanced inspection task, our coding-free interface is the biggest selling point. All of the configuration has been already programmed in our interface. It is very suitable for the engineers who want to hands-on the AI tool immediately. And second is the principle of AI is much easier than the programming, traditional role-based programming way. You just need to simply input a good sample and not good samples, which means images into our data training. AI training model is able to perform like the human-like recognition ability. So, for example, some of the master inspector in a factory, if today they didn't work anymore, you don't have any skill to pass down those ability, those experience. But by using the image recognition, which is the most easy way to pass down his ability to do what is okay, what is the not good samples. So this experience could be exactly copy in our AI learning model. And some of applications is hard to be implemented by the rule-based algorithm, simply because some of defects is so hard to be programmed, to be described. Could be very variable, like a scratch on the surface. Could be, for example, food industry. You have different variable defects. Simply a single algorithm cannot describe all of them, cannot program them. So AI-based is another way out for you to learn from the pictures and to tell what is good, what is bad. And fourth point is we provide ready-to-use camera like Bachelor, Hikvision, and Tele. Those 3 brands we already integrated. And for some developer, we also offer you SDK to integrate the interface with your system. So as I mentioned, the rule-based versus with AI vision is actually fundamentally different. We don't use the traditional way to describe what kind of, for example, here you see metal surface inspections. You have to describe what is the scar or crack looks like on the surface. You have to maybe limit it on the size or the color. But you sometimes even overkill or miskill those defects. Those are the problem of the traditional rule-based tools. However, AI deep learning, you can see from the right-hand side, we learn those defects, how it looks like. And we learn from the pixels, we analyze those into our AI model, and we generate a human-like AI model to inspect those defects. So we have a 4-step to set up the SolVision. First, from the camera selections. Second is your hardware camera and lighting setup. Third is AI model training. And fourth is after you training, how you integrate with the robot and POC. As I mentioned, these 3 brands already integrate with SolVision on the interface USB 3 or Gig E. And if you need your own preferred camera brand, we also offer you SDK in C#. You can do by your own. So it's very, very flexible. And for the camera setting, first of all, you need to tell us what's your field of view, how big the area you want to inspect. And after describe the area, you tell us what's your defect size. For example, here we have a PCB board. They want to inspect some 0.5 millimeter defects on the PCB board. So this is very important for us to refer to the FOV and the defect size. We will suggest you the camera resolution you need, because this need to compensate with our software ability as well. And some detailed spec like shutter, sensor size, and lens, those could be advised by the local camera manufacturers. According to your working distance limitation or according to your installation environment setup. And don't forget, the lighting is actually the key important point you can be success in the SolVision, because some of defect is so hard to just simply use the human eyes to see from the ambient light. Sometimes you need a artificial light to shoot from the right-hand side or the left-hand side or top. So the skill of the lighting setup is actually what we rely on the local partners who should have the ability to know how to present those defects. And after you present those defects by camera, you send us those pictures, we will start to do the AI training. So AI training is actually quite simple to be designed in the beginning. We only have 4 major functions. First is called feature detections. Second is instant segmentation and the classification. And finally, the anomaly. We could combine those 4 functions. You can play around. You can use first the feature detection and then instant segmentation, or either way, or vice versa. So multi-layers is one of our features. You can combine those tools and to be more powerful in your task. Feature detection is more suitable for your parts if they have a rigid shape, they have a regular shape. You can easily use the square-like tool to feature out where it is the defects you want to inspect. For example, on the right-hand side, you can see this is kind of pattern check on the surface. Actually, the pattern inside is different. So feature detection is easy to square out where is the area you want to inspect. So in this kind of regular area inspections, we will use the feature detection tool to inspect any surface issue. Instant segmentation, we provide you most variable tools for you to draw the defects you want to annotate. This is for irregular shape. You want to draw in the multiple size, and you want to create the different classes in your defects group. So instance segmentation is actually the most common tool we use in the AI training. The classification one is quite simple because you classify the whole pictures. This could be easily used in when you have a clear objects in the middle of the pictures. For example, here I have a food boxes, and I want to classify this is cheese, this is sauce, and the noodle. So they will consider the whole pictures, the whole features in the in this image, and consider all of the points of this image, and to classify what is the feature inside. So this is the tool you can use for the big objects. Okay, and after you program those AI model, after you finish, we are able to connect with either PLC or the robot. This is what we actually strong, because remember we have AcuPic and SolMotion. Both solutions are connected to the robot perfectly. So SolVision is actually also the legacy of those two products. So it is easily to communicate through TCP/IP to with the robot, or you can write the programming to communicate with the PLC. So for the following time, I want to do some live demo. Actually, it's not live, but I want to use some pictures to introduce you some projects. Okay, so let me switch my screen. Okay, so first projects, I would like to introduce the glass. If you remember, I introduced this one in the presentation. Okay, this is from one of our cosmetics customers. They want to inspect some defects on the surface, like a crack, a scratch, or like a bump or dust, those defects. So in the beginning, we will have to, first of all, we have to highlight where is the glass. We don't want some noises in the background. So we use the feature detections here. We use in total 8 pictures to square out where is the glasses. And second, I use the cutting tool. We call crop or rotated tool to highlight, to crop out where is the glass. Okay, so right now we don't have any background noises. We can start to do annotation. And as you can see, the glass has 4 sides. So you will see the top view, bottom view, side view, in total 4. Here we simply use the 11 images to do the deep learning. I create the class is called A class. And for these 11 pictures, I already label 18 objects. So you can see, for example, here, this is our defects. Here you can see the original looks like this. It looks like a black dust on the surface. So for example, if I delete this one, I will use the polygon tool to highlight this, to annotate, because it looks like irregular shape. That's why I'm selecting the polygon tool. Okay, after I label, I can click S. Okay, like this, and it is done. You have already labeled these defects, and you can simply copy this to the different places. Also, you can delete it or rotate it as you want. So this is how simple we can highlight the defects here. Also, you will see those small defects. We will use those tools to simply highlight to draw where is the defects according to the end user requirement. Maybe they have some human experience. They will have to describe you what is the defects here and what is not. So after training, we will put those pictures into the deep learning model. And here, you don't have to worry. This is according to the dimension setup. We will put some parameter here. So you will click yes, and to start to do the deep learning. Usually, if you only have 11 photos, images, the training time could be pretty short. So you will see here we need 8 minutes, 6 minutes. It's jumping because if the data can be converged, the training could be even faster. If they find a common features, common, let's say, interest region. So those is the presentation of our training model process. So I won't keep you guys waiting here 6 minutes. I will just simply stop here. Also, we have a data augmentation tool. It is friendly for you to create more situation by adjusting the resolutions, the light and the colors, brightness, contrast. Those are the tool for you. Don't have to keep shooting the images to our system. You can create from the data augmentation. And after you training finish, this is your training data, and you will see those detection has been done. So we can put some real photo here. So in total, I put 22 photos here to see, okay, if my training model has been correctly highlighted. So I will run a little bit the modeling and to validate if the model has been done. So for example, I'm sure this 17 is the pictures I never labeled before, but still you can see from the detection, I could still clearly see, okay, those are indeed the defects and has been highlighted already. So this process means, okay, your model has been created quite good and easy. Also, if you want to enhance the model, you can move this detection result to the annotation and to enhance again your training model. So this is like the system you can easily play around. And honestly, I'm as a salesperson, I'm not an engineering background. Just play for 1 or 2 or 3 times. I have been already understood what I'm doing already. By this simply input the data, label, training, and modeling. And finally, you can have the analysis to see your training data sheet if it's what you want. So this is the first projects I would like to highlight with you guys. Let me switch back. Okay, so we realized this surface inspections is actually quite AI inspections favorite projects, because the surface is always hard for the rule-based algorithm to describe. Also, for example, the chicken nuggets, we have one project in Taiwan. You have to inspect the black dust, oil dust, brown or overcooking or oversized, or we call twins, chicken nuggets here. We have to inspect out. So in total, we implement our system on the production line. We have control 2 to 4 cameras on the top, and we have to inspect those defects correctly on the conveyor. And they will use some automation system to reject those products. Also, this is another surface inspection example from India. The customer wants to inspect the painting surface. As you see, here are some scratch or some damp. And by using the UR robot with the camera and the brush, we could inspect where is the defects and to control the brush go down to do some clean. So this is the service we can do for the surface inspections. It could be the metals, it could be the painting, or it could be the plastic. So the market is big, and this is still undeveloped market for you guys to discover with us together. Okay, so the second segmentation I will say is grading and classification. This is easy by using the AI inspection than the traditional algorithm as well. So I will play the video here. This is traditional way. After the X handled by the conveyor, the human need to use the eyes to see if there is the problem on the eggshell. They have label 1 as a perfect egg, and the label 2 as a medium perfect, and the label 3 is quite bad because they have some crack, they have some fragile patterns on the eggshell. So the job for AI inspections is to do grading for this 3X type. And this is our POC machines. You can see we need a lighting system, we need a handling system to highlight those defects on the eggshell. So today I will also quickly go through how it works in our interface. So let me switch again. Okay. So this file has been already programmed. I'm just simply load it, and you can see together I train 123 images from the machine I present. So you can see, okay, I have 3 classes, level 1, level 2, level 3. And if you see from the naked view, you will see, okay, this one looks quite bad. This one looks quite bad as well. This is good. This is medium. So, well, this could be defined by the end user. It doesn't need to be defined by you. But anyway, we discussed with customer, and we used also the polygon tool to highlight those X and define them into different classes. So you don't have to write a program to describe how does those X look like. I mean, in terms of the patterns, which is so hard because it's quite variable, right? It's basically based on the human experience as well. But the AI can to converge those experience into one model to help you to really truly free those experience freely to the automation. So you can see this perfect egg. You will see I label in as a label 1, and those are not labeling the label 3 and 2. Okay, so again, after labeling, I put in the model, and after modeling, I will do some validation in this case. So I also need to take some photos of those eggs and to check if my model works well in this data learning, because this is quite simple, easy task. You can see all the eggs are in the regular shape and there is no overlap. So we don't need to learn too many pictures. In total, I only learned 120. It already works well in the reality. So this is how we do with the AI training in the X. This is holding too long, so I'm going to just stop this so far and switch back the presentation. Also, this is one of the example in Taiwan. We have to classify the bread into the different label. It could be also using to the fruit, using to any kind of food factory. If you need to do the classification, AI can definitely help. This is also the textile company. We have partner in Mexico. We have a different type of textile, and from the human visual, it's hard to see, but the integrator, they have a good skill to present the textile in the detail. So you can see this is how our integrator send us the pictures, and it's actually quite different when you take in the photos from the background light, and also with the good camera. So we do some deep learning. This is the result. We can clearly see the different. If you see the gradient here, means that almost 100% similar to what you define. Okay, so we use a classification tool in this case as well to identify two different textile type. Okay, so the last page, I would like to introduce you the scenario to check absence and presence in the food industry as well. This is one of our customer. They have you can see the food box on site. They are doing some filling process. Well, the issue is on the edge of the lunch box is not allowed to have those sauces spread around, because when they are doing the hot sealing, the edge with the sauce could fail the sealing. So our AI need to use the really easy way to learn what is the sauce on the edge. We don't need to do programming to describe those different sauces, but we just learn from the pictures. So the last one, I will also show you in the interface. So let me just quickly load the Foodbox projects. All right. So again, I only simply use one tool. It's called instance segmentation to finish these projects. You can see the customer send us a bunch of the different images, and my job is to do annotation on the area. Our customer think is the defects should be inspected. For example, the area leaves, or here, those are the food leftover need to be inspected. Okay, so I also simply just use the tool. When I go to annotation, you can see, for example, this noodle, I use polygon, and I just simply highlight how it looks like. Okay, as simple as this is done. And I create the most simple scenario and put it into the model, start to modeling the AI model. And then I use another 78 images to validate if my model is correct or not. And successfully, my model running really well. In this case, I only use about 50 or 30 pictures, but I already can start to inspect. So the whole process takes the programmer less than a day. This is compared to traditional algorithm, really help the end user or help the integrator to save a lot of time and money on site. And I think this is truly the power of the AI. Can be really easy to program and can solve the problem which algorithm base is hard to describe or to solve. Okay, so again, this is running a little bit too slow. So I think I will, okay, this almost finished. Okay. Okay, it's show already. So those pictures are the one I didn't learn, and I still need to see, okay, if I can successfully inspect them, or I have to put them into the reinforcement to the model and do another annotation. Okay, so this is pretty much the SolVision webinar today, and we offer the either end user or integrators for the free test. You can simply describe your problem to our local distributor, or you can direct contact us. And if some senior programmer want to test our software, is also available. Just register online, and we will contact with you guys soon. Okay. All right, that's exactly 40 minutes. And I will look up you guys on the internet. See you guys soon. Okay, thank you. Bye-bye.